Video we place the player and the exit on the board. Now what we like to do is to put walls around the room. Now keep in mind that the exit, as we put it, can be on the border. So when we put the walls, we need to be sure that there is nothing there before we place the wall. If it's something, we'll just not place a wall in a given position. And we'll start by placing, let's say, the vertical walls that are on the first and last columns. So to do that, we need to go through all the rows. So we'll have a 4 with an index that will go from the first row until the last row, and we'll go row by row, and if we can place the wall, we'll place it. To check that we can place the wall, we need to check that the room at this position and column 0, if this row and column 0 is equal with an empty space, which is a dot in our case. And if this is the case, means that I can place here a wall, because I don't have, the only thing that I can have for now is the exit. And we'll place the wall by putting this character inside the matrix. Now we did this for the first column. We need to do exactly the same for the last column on the same row. The last column will be at the length -1. This is the last column, and we check if it's empty. And again, if it's empty, we'll place in this last column on the row I, we'll place the wall. So let's see what these first two walls looks like. So let's run the length. Let's put a small one, 5 and 7. And as you can see, I have the two walls, vertical walls. Now, what we'll need to complete with the horizontal walls up, top and bottom. And these ones don't need to go from the beginning. They can start with the second position and finish with the second to last. So let's use a J now, and I said that we don't need to start from 0 because we already put it when we did the vertical walls. And here we'll go to length less than the last one, which is length -1. So we'll stop before the last row, and we'll place on all columns for the first row and the last row. And again, we need to check that the exit is not on one of them. So the first row is row 0, and we want to place on the column J, but needs to be empty to be able to place something there. So we test that it's empty, and if it's empty, we'll place in this cell the wall. And we'll do the same for the last row, which is length, which is width -1. And on the column J, if it's empty, we want to put in this last row on the corresponding column, we want to put the symbol for a wall to put, and this will complete the border around our game. So let's put the length of the room 7 and 5. Okay, we make a mistake here. Here we have this -1. Let's try again, 7 and 5, and as you can see, it will generate this border around the table. Now, if we run several times, we'll see that the exit may, let's put here 4 and 4, and this is the exit may go on the border, but the player will be always inside. So this is a good test. If you want to test the program, you can put the minimum size and also big size. Now, what we want to do now is to place obstacles inside our matrix, and we need to be careful not to put too many obstacles. We said, okay, we don't want too many, and I put here a condition that was 2 times length plus width, but we can do a better condition. For instance, we know how many spaces, empty spaces we have, and we may say, okay, I want to be less than a given percent of these empty spaces. For instance, less than 10% of the empty spaces, so only one obstacle for 10 empty spaces, or 20% or so on. So we can decide how many obstacles we want, but not allowing a too crowded room, because then you will not be able to move at all. So let's put, we want less than 20%, so 0.2 times the number of cells, which will be length minus 2 times width minus 2. So this will give us around 20% from the capacity of the room, which will be the maximum that we allow for the number of obstacles. So to reach the obstacles, the number of obstacles, will use the same kind of structure like we have to read the width. We'll need to move the close for the scanner, because now we want to read something more. We'll close the scanner after that. So let's put here an int with number obstacles, and we want to read this one. First we give a short message to the user to know, enter your number obstacles, and we're reading in our variable from the keyboard, using the scanner, and read the next integer. Now we'll have an error if the number of obstacles is less than 0. We cannot have negative number of obstacles, or if the number of obstacles is greater than this very complicated expression that we created, width minus 2 times length minus 2. So if our number of obstacles is greater than this number, it's too big, it will be too crowded. So we can put an error message, invalid number of obstacles, and repeat the reading until a correct value is provided. So we'll do this while we have an error. Now, once we have the number of obstacles, what we like to do is to place this number of obstacles inside our room. So we know that we want to place, let's say, O from 1 to number of obstacles. So we want to place this number of obstacles, and in order to place them, we'll try to randomly detect a position until we find a good position, an empty position to place the obstacle. So it will be very similar with how we generated and place a player, except that now we want to generate and place obstacles. So we'll have an obstacle row and we'll have an obstacle column. And to complete the obstacle row, again, the obstacles we already know that on the sides are occupied, so we don't need to duplicate that. We can directly try to place inside the obstacle, and then we want to check that the room at these coordinates is empty, and if it's not empty, we'll repeat until we find a good position for which the room is empty, and then we can put obstacle at that position. So this will conclude the placing of the obstacle. So let's see how this works. Let's say we have 10 by 10 and we like to have like 15 obstacles. 15 needs to be correct because 15 is less than 20%. Let's see how we read. So we have error if it's greater than 15, no, because it's 8 or 864. Yeah, so it's right, it was too big, so 15. So let's say 10, 10, and now I will put only 7 obstacles. And as you can see, I have the exit here, I have the player, and then I have 7 obstacles between them. Sure, it's pretty empty. We can always relax the condition for the number of obstacles. We can say, okay, let's put 30% maximum obstacles, and then we'll be able, when we run, to create a more crowded, like here we'll have 8 times 8, 64, 64, we can put even 18. So let's put 10 by 10, and let's put 18 obstacles, and now it's much more crowded. And you know, being very crowded, you may even, like in this situation, the exit is blocked. You need to have a way for the player to destroy the walls to reach the exit. So this concludes our first activity, and we are able to generate a room with obstacles, with an exit point, with walls around, and the player position.